When computing the double integral, it is convenient to consider special type of the integration domain D. And we introduce normal or standard domain of two types, type 1 or type 2. Type 1 is a set of all pairs xy from R2 such that x is from some interval AB and then we have two functions phi1 of x and phi2 of x that bound y. So phi1 is some function, phi2 is another function, it should be not less than phi1, and then the integration domain is this set. Right? And the type 2 standard domain is a set D of the pairs xy from R2 such that y is from some interval CD and then again we have two functions. This times we use the function as a function of y, psi1y which will be the lower bound of x, and psi2 of y, and then we consider this set. And it will be convenient, it will be possible to integrate functions over these special type of domains. Sometimes a set is both of type 1 and type 2. If you consider an ellipse like that, then you can think of A, the leftmost point and its x-coordinate, and B, the x-coordinate of the rightmost point, and then y is bounded from below by this line, which can be considered a graph of the function phi1, and y is bounded from above by this line, which is the graph of the function phi2. But at the same time, this very same set can be considered as a type 2 standard domain. Namely, if you consider the bottommost point and its y-coordinate C, and the topmost point and its y-coordinate, let's denote it D, then x is bounded from above, one is tempted to say from the left, from below, by this curve, which can be considered a graph of the function x is a function psi1 of y, and x goes up to points on this curve, which can be described as a function x is psi2 of y. But sometimes, however, a shape like that it is quite straightforward to consider this as a type 1 domain. This is this is phi2 and this is phi1. While it is not possible to consider this set as a type 2 domain, because we can find the bottommost point and the topmost point but then for some y, x is from this interval, but from other y value, but for other y values, x is not from an interval, it is from a union of two disjoint intervals. In this case, one might cut the set into two parts, and then we can describe each of these two parts as either type 1 domain or type 2 domain. So sometimes it will be necessary to decompose the integration domain into smaller parts, into smaller subsets.